So I got up this morning and I come walking in the kitchen to get a cup of coffee. All the shades were closed, so it was dark in here. And I came in the kitchen, I nearly crapped my pants because I saw this. I don't know if you can see it. I thought it was a scorpion. It's just thread.
I almost hit it, so I imagined that probably.
Yeah, when you noticed when as we were going that it settled down in a seat.
Maybe like far out.
You hear me?
Yeah, can you hear me?
Say it again?
Can you hear me?
Say it again?
Can you hear me?
Say it again?
Can you hear me?
Yeah. Driver isolation was on.
How do I... The blower's not on, right?
No, not yet. Get this. We're okay.
Your oil pressure as well.
It's alright. In idle, it'll be okay in the teens.
Okay.
We clear that way?
Clear right.
Okay, hey everybody. All right, so a lot going on. First off, we took the truck out last weekend and did a little bit of testing. We only could free up one day, but our main objective was just to test out the cooling system to see how well it was going to do. It was about 100 degrees outside, and we took it out and made it about, oh, I don't know, 5 miles into our test run, and everything was going great. The temperature, we were maintaining about right around the 200 degree range, which I don't like. Everything was running fine, so we brought it back, double checked the coolant system to make sure we didn't lose any coolant, we didn't have any leaks, because I made quite a few changes that I'll go over in a minute. But I want to keep it around the 160, 180 range. We noticed that our oil pressure, Julie was driving with me and she was keeping a close eye on everything, and we noticed that when the temperature went up, our oil pressure dropped and fluctuated. Now, as you know, we're running a dry sump system. It's a Peterson system. It's got a 5-gallon oil tank that drains into a sump on the bottom of the motor, and all that is pumped and circulated by external belt-driven Peterson pump. It's a 4-stage system. So basically it has 2 really big 12 AN lines that scavenge the oil from the bottom of the motor and then pumps it into a tank where it swirls it to keep residue and contaminants out. And it also cools the oil, and then it's pumped through a filter. It's pumped out of the tank, through a filter, through a cooler that's also has its own fan, and then back into the motor, and the process just repeats. So I know that we're running the pump around 60 psi. So at RPM, when we're running it, you know, wide open or mid-range to wide open, it should be pushing close to 60 psi, and we noticed that we were dropping pressure. So I think that's contributing to the heating issue. I think our coolant system is good. Now it's an oiling issue. Every time we run this, I drain the oil, I open the filters, and I look for metal, and we haven't had any. It all comes back good. We run a really good Penn grade racing oil. It's a high zinc oil. So to go back a little ways, when I had this motor built, it was probably 7 years ago, when I had it machined and all the machine work done on it. At that time, I wasn't planning on running a dry sump system, and I got to thinking that the machinist probably didn't do a particular operation inside the motor that on these early LS1 LT Vortec engines you have to do if you're going to run a dry sump system. Let me draw it and see if I can explain it better. Let me get a whiteboard here. So here's our engine, and this is just going to be a crude diagram. This is looking to the front. Here's your crankshaft, your timing. These are the heads, valve covers. Our oil pump is right here, and it's belt driven. And then this is a sump, and our oil tank is way over here. Basically, inside the motor, if we were running a stock pump, we wouldn't have this shallow sump pan. We would have a larger oil pan. And inside that oil pan is your oil pump. It goes down to a strainer. This is your pickup. This is normally your oil level. and the oil is pumped in and then over to where your stock filter would be. We're running a remote filter. Our filter's located off the motor. The oil comes in through this little passageway down through the filter and then back up to all the galleys where it oils the top of the motor. On this style engine block, there is a port, a hole, a passageway that connects here to here. It's called bypass. Okay? Now we're not running this. Our oil pump has a line that supplies the engine directly into the stock old oil location, and it just pumps the oil straight up. This isn't here. So basically what we have now, we go back to the sump picture. So basically what we have now is just an open hole that's about the size of my pinky finger right here. So my theory is that we're pumping oil in, and when the oil's cold and thick, it can push up enough and not go down this bypass. But when it warms up, the oil gets thinner, and basically what we're doing, we're losing pressure this way and less this way where it needs to go. If the machinist had built the engine in preparation for a dry sump system, this is blocked off. They put a little plug in there. I bet you that little plug isn't there. And so we're losing a ton of pressure through this big giant hole right here. It's turned into kind of a scribbly mess, but hopefully you get it. I think that is our problem. A minor little oversight that goes back almost 10 years, 7 years ago, whenever I had this engine built. I bet you that's not plugged off. Now, the engine's in the truck. I can't take it out. I mean, it could, but it's a lot of work, and I'd have to tear the whole bottom end of the motor apart to try to get that plug in there. And I'm not capable of doing that. I don't have a machine shop to do that. But what you can do, and this is what Peterson told me, is they make a plate that bolts in place of where the stock pump was, and it blocks it off here. So basically it blocks off all of this big hole, and then it allows our oil pump to pump all 100% of its oil capability up here and not down. Does that make sense? I hope so. It's a pretty crappy drawing. So anyway, that's what I'm thinking. And then another thing that I'm wondering is the engine is right in here, and it's fully encapsulated by a lot of aluminum tin work and doesn't have much airflow around the outside of the engine because of all the stuff. So what I'm gonna do is strip the body off, strip all the tins off. I'm gonna cut some screened vents in the tin work through the front here, open this up so we get airflow around the motor. I'll cut some vents up top so the air can go escape, the hot air can escape. And then also I'm gonna drain the oil because it needs to be drained anyway. And I'm gonna drop the sump pan, and I'm gonna put that little blocking plate on the stock oil pump hole. Because like I said, it's a big hole, and we could lose a lot of pressure through there. I'm almost 100% sure that's our issue that we're dealing with right now. And again, it's a good built motor. We run really good oil. It's changed regularly, so I don't think we've hurt the motor at all. It runs great. We're just a little low on oil pressure, and I think that's contributing to the cooling issue. So that is where we're at. And then I get that done this week. We're gonna go out next weekend and do another day of testing. So this is my list right here. You know, basically what I just said. And then I'm gonna tighten all the AN lines because we have a couple that are leaking a little bit. Yeah, and I'm also gonna relocate our temperature sending unit location. It's on the top of the intake manifold right now, and Peterson recommended, and General Motors recommends, that the sensor be located on the side of the head, on the driver's side bank head. You get a better accurate reading down there. Yeah, that's where we're at. Also, I've got video that's coming out next week. I attempted to wrap my Dodge with the vinyl wrap. I want to wrap the bed and then have it taper down and put the Parabellum logos and stuff on it. And I've never wrapped a vehicle before, so I thought it'd be a good video to try. And it was pretty frustrating, but I'm going to finish that and get the rest of that video done, and that'll be released in the next week or two. Hopefully when it's done and it looks okay. But right now I've got one panel on my truck black, and it looks kind of goofy, so I need to finish it. But I think I learned a lot, did some YouTube searches, and I think I'll figure it out. But Julie was helping me, and she was doing a great job helping me, but it was getting really frustrating, and I was kind of losing my cool on it a little bit, so I just had to walk away from it. So I'm not going to put that video out this week. I'll do it a couple weeks. But I'll share what I learned doing it, and hopefully it turns out okay. But anyway, so yeah, today I'm gonna get the truck stripped down, and hopefully drain the oil and do everything I just said, get some vents cut, and try to get that old oil pump location blocked off. So all right, let's see how it goes.
Give me hope.
I got the sump out. To get it out, I had to drop the starter and the oil pump, but that's okay because I gotta look at the lines on those anyway. But this is the sump. It kind of resembles a normal oil pan. It's really shallow. This is a windage tray. As the crankshaft spins, these scrapers scrape off any excess oil, and then it falls down into the sump, which is this section here that's lower, and then the scavenge lines suck oil. The pump sucks the oil back up to itself, goes through the pump into the top of the tank. So everything looks really good. The oil's nice and clean. There's no metal in it or anything. The magnetic plug on the bottom just had the normal residue that you would see, but no big chunks or anything. Let me get a flashlight. I think I have a light somewhere. Let me find a flashlight and then I'll climb underneath and show you where we got to plug the hole. Okay, climb under here without banging my head. All right. So right here is where the factory oil pump would go. It would hang way down. I can't use a factory oil pump because I don't have the clearance under here. And a dry sump's just better. Like, I just drained 5 gallons of oil out of this, so that capacity not only is better lubrication but better cooling too. And where we're running into our cooling issue is this hole right here. We're losing all of our pressure through that hole because this needs to be blocked off. So they make a plate that goes right over this and just seals it off. And it's held on by the center bolt here. So you can see that's threaded, if you can see that. So I'll just make a plate out of some 1/4-inch steel, maybe even some aluminum. And you put a little bit of Permatex sealer on there and bolt it up, and it blocks off that bypass hole right there. So that's it. Everything else looks really good. Camshaft looks good. I can see it up there. Looks like it's wearing nice and even. All the pistons look good. There's no chunks missing. Yeah. Watch out, Leo. Gotta get my fat boat out of here. Okay. All right. So I'll make a plate, block off plate, and then get it all buttoned up. And then while I got all this out, I'm going to relocate the water temperature sending unit too, from the top of the motor down to the side where it should be. So, all right, so far so good.